At a local college, 75 male students were randomly selected and their mean monthly income was found to be 654. So we have 75, that's N1, and their mean X1 bar was $654. With a standard deviation of 100, okay, here, one thing I wanted to just add here with a population standard deviation. I wanted to add a population standard deviation. I missed that word. So sigma 1 will be 168.70. 65 female students were also randomly selected. So that's N2. So we're comparing male and female, guys. And that's female here. So N2 is 65. Were also randomly selected. It was found that their monthly income was 612 with a population standard deviation of 121.50. So X2 bar is the mean. This is the mean, which is what here? 612. And sigma 2 is 121.50. Test the claim that male students have a higher monthly income than their female students. So higher monthly income, guys, which one would that be? First, second, or third? Remember, 1 represents male and 2 represents female.
3.
3, because we want to check that the males make more than the females. So it will be mu1 greater than mu2. And look what I put here, guys. Mu1 is greater than mu2. That's the claim. Then the null hypothesis will be mu1 less than or equal to mu2. So here we start with the alternative, and then we can write the null hypothesis. Okay, since I say population standard deviations are given, guys, you have to use a 2-sample z-test. And let's show you. I already have the calculator screenshots, but let me show you how to do the problem. It's not difficult at all. So you go to stat, you go to tests, and 2-sample t-test, z-test. It's number 3, guys. There you go. Enter. Data, not data, stats, summary. I don't have data here. And look, first one, sigma 1, which is 168.70. Sigma 2, 121.50. X1 bar, 654. N1, 75. These are the male data. Now the female data. X2 bar, 612. N2, 65. And now, guys, be careful with this. You need to choose the sign that you see in the alternative hypothesis right here. I see a greater than, I need to select a greater than. So go to there and then hit enter and calculate. And Z is 1.71 if you round it to 2 decimal places. And p-value, guys, is 0.0441.
I have a question. If you accidentally put in like the data, if you swapped it for the 1 and 2, would it become the same answer or no?
What do you mean? If you
I mean, like if you put in the male as N1, like if we accidentally put in the female information as like
oh,
N1.
then you have to test. No, it will be wrong. You will need to test that the females make less than the males. Does that make sense? If I make more than you, that means you make what? Less than me. Does that make sense? So then, yeah, you have to switch the sign. It will be here. You will have to do less than.
Okay.
Because if the male make more than the female, that means the female students make less than the male students. So if you switch it, you will get the same results. That should work. Yeah. All right, guys. So we got. We need to test. He didn't say alpha. Oh, alpha is 0.01. So we got Z equals 1.71. I'm gonna write it down. It's already written there. And p-value, guys, which is 0.0441, which is bigger than alpha. We fail to reject the null hypothesis. Okay, let's write the conclusion, guys. It's already written on, I'm gonna write the conclusion here. So there is not enough. Okay, how did we decide we put not here? From the word fail. Remember the link, guys. I'm not changing anything today. There is not enough evidence at the 0.01 level of significance to, what's the magic word, guys? Support or reject. Remember, the claim is in HA. So what would be the word here?
To reject. Oh, HA, support.
Support, yes. We don't have enough evidence to support the claim. To support the claim that male students have higher monthly income than female students. We're not saying that we are supporting the claim. We're saying that we cannot support the claim that male students make more than female. Although the sample size reveal a sample mean of 654, but the women, it's 612. Standard deviation make a big difference. The male have a larger standard deviation than the female. So that's why it could be the reason why we could not support that. So just keep that in mind, guys. If you make more money than one person in one day work, it doesn't mean that on average you always make more money than that person. Maybe this particular day you worked more hours, than the other person, but probably the other person, will do more hours later in other days. So one piece of data doesn't confirm, just results. And that's why we have to perform hypothesis testing. So here we concluded that there is not enough evidence at the 0.01 level of significance to support the claim that male students have higher monthly income than female students. Okay, so that's section 8.1. Let's do an exercise on section 8.2 now. There you go. I got a nice worked out exercise. Okay. I'm going to pause the recording in order to put the data in L1 and L2. A sports analyst claims that the mean batting average for teams in the American League is not equal to the mean batting average for teams in the National League because a pitcher does not bat in the American League. The data listed below are from randomly selected teams in both leagues. At alpha equals 5%, test the sports analyst claim. I mean, he says it clearly that the batting average in American League is not equal to the mean batting average for teams in the national average. So you guys, you should agree that not equal, it's right this. Mu1 is different from mu2. We're labeling this as mu1 and we're labeling that as mu2. Usually, guys, the first piece of information should be labeled as number 1 and second piece as number 2. So can we guys agree that this is are you convinced that this is the correct claim? Because we need to check that mu1 is different from mu2, and that's the claim. So that will be mu1 equals mu2. Okay, he says assume population variances are equal. Once he make this assumption are equal, not equal, that's a pooled, guys. So that means it's a two-sample t-test. He didn't mention population standard deviation, so this is a two-sample t-test. Okay, and let's perform the test and show you how to do it. So you just quit here. You go to stat, tests, and all the screenshots are given in the handout. So 2 sample t-tests, guys, watch. Enter. This time is data because I have raw data. We entered data. Okay, let's confirm. Is my data in L1? Yes, the first set is L1. L2, don't change these two. Never. 1, 1. Remain 1, 1. Okay, can someone tell me what's the sign is going to be here? First, second, or third?
First.
First, I agree. Okay, for pooled, guys, let me remind you again. If he says the population variances are equal, pooled is yes. If he says the population standard deviations or variances are not equal, that means the pooled is no. So equal means a yes, and not equal means a no. So I'm going to select no here, and I'm going to hit calculate. And look, T is 0.15 and p-value is 0.88. Okay.
Professor, really
Yes.
quick question. So how do you distinguish whether it's a t-test or like what was it that you know?
Okay. If he gives you those two values, watch. Sigma 1 and sigma 2, which is called the population standard deviation, it's a z-test. If he doesn't, it's a t-test. And here he just gave me a raw data set, so it's a t-test. But if he mentions sigma 1 and sigma 2, then it is a z-test. That's a good question, and that's the most important question, actually, how to distinguish between the two. And guys, I didn't record the last part. So what we said, we did the 2 sample t-test here. Stat, tests, 2 sample t-test. And then L1, L2, I asked you for the frequency, don't leave them at 1, 1. And then we did not equal to. For pooled, because the population variances are equal, we have to select a yes. Oh, probably I put a no by mistake here because it says population variances are equal. So let me double check and enter. So negative 0.117, yes, and the p-value is 0.9089, which is more than alpha. We fail to reject HO, and we conclude that there is not enough evidence to support the claim.
So when you pooled it, it should have been a yes, not a no?
Yes,
Okay.
definitely. So let me write them down for you guys here. Population variances, I'll keep reminding you for this, are equal, implies pooled, yes. Population variances. He has to say that in the question. Are not equal, implies pooled, no. You know, I teach using a different textbook with another group, and by default, the author tells them, if there is no mention here, you just assume it's a no. But in your book, he will mention at the end of the problem whether he wants you to use a yes or no in section 8.2. And that's all, guys. This is a good example of what we did in section 8.1 and 8.2. What I'm going to do now, I'm going to show you, I'm going to do 8.4 and show you it is as straightforward as the previous two sections.
I have a quick question.